So imagine you're handing a master builder a flawless, mathematically perfect blueprint for like a towering skyscraper.
Right.
Every single beam is measured, every material is specified. But then you walk away and the builder decides to just swap out the reinforced steel for aluminum.
Oh, wow. That sounds...
Yeah, because they just assumed your load-bearing calculations were, loose suggestions.
Right, just guidelines.
Exactly. So the building goes up, it looks great for about a day, and then it just completely collapses under its own weight.
Which is terrifying.
It is. And that catastrophic miscommunication is exactly what happens, like every single day in the tech industry when digital product design is handed over to developers.
It really does. It's so common.
We treat the visual design like it's the finished product, right?
Yeah.
We just throw it over this imaginary brick wall and act completely surprised when the coded reality looks and feels entirely broken.
I mean, it's easily the most expensive point of failure in software development today.
Oh, absolutely.
We spend all these weeks or even months agonizing over user psychology and the typography and, the interaction patterns.
And then what happens?
We just watch it all unravel in the translation. From this static canvas to a dynamic code base.
Yeah.
And the friction isn't usually a lack of skill on either side,
Right, it's not that developers are bad or designers are bad.
Exactly. It's a fundamental breakdown in how the two sides perceive the medium itself.
Totally. Well, welcome to the deep dive, everyone.
Glad to be here.
If you're here, you're someone who wants to cut through the theoretical fluff. You want to avoid the information overload and grab the hard technical realities that actually move the needle in your career.
The practical stuff.
Exactly. So today, our mission is to break down the core design concepts for someone just starting their career.
Right.
We're specifically focusing on that terrifying leap from a static, idealized design to a living, breathing, coded product.
And to do this, we are pulling our source material entirely from Chapter 28 of the phenomenal book, Design User Interface.
Specifically, the chapter titled Developer Handoff.
Right, Chapter 28. It's a crucial chapter because it treats the handoff not as an event, but as a continuous technical discipline.
Absolutely. It's not a one-off thing. And I want to make sure you have this resource open and ready as we get into the weeds today.
Definitely.
The specific link for your reference is https://hype4academy.gumroad.com/lubook.
You want to bookmark that.
For sure. You can actually seamlessly buy the book right now by scanning the QR code of the book link provided in the description below.
Do it now while we're talking.
Yeah, do that now. And while you're at it, explicitly follow the show right now for more technical design breakdowns and career building content.
We've got a lot of ground to cover today.
We really do. So let's just start by destroying a myth right out of the gate.
Let's do it.
The traditional concept of the handoff implies finality, right?
Right.
Like the designer finishes the mock-ups, exports the icons, maybe writes up a quick style guide, and then they just walk away to start the next feature.
Yeah, that assembly line mentality. That is the root cause of the skyscraper collapse you mentioned earlier.
The structural failure.
Exactly. The source text strongly argues against this compartmentalization. The designer's job does not end when the Figma file is locked.
It doesn't.
No, it expands. The designer actually has to transition into playing a critical role in the QA, the quality assurance process.
Okay, wait.
Working directly alongside the developers.
I have to challenge the premise of the designer acting as QA here.
Go for it.
If I've built a high-fidelity, fully interactive prototype, meaning like the client can click through it, the animations trigger perfectly, all the states are mapped out, my work is fundamentally complete.
Is it, though?
I mean, my intent is explicitly documented on the screen. If I start hovering over the developer's shoulder during the build phase, that just feels like micromanagement.
Right.
I'm basically telling them, hey, I don't trust you to copy my work.
Okay, but that assumes your prototype and their code are operating in the same physical reality, which they aren't.
What do you mean? They're both on a screen?
Sure, but a prototype, no matter how complex it is, it's just a controlled simulation running inside a vacuum.
Okay.
It doesn't have to contend with the browser's document object model or the DOM. It doesn't deal with the latency of an API fetching data or, the reality that the user's device might be running low on memory.
Oh, like when a phone is just lagging.
Exactly. And that memory issue causes your beautifully smooth 60 frames per second animation to stutter and drop frames.
So you're saying the prototype is like a lie we agree to believe for a little while?
A very useful lie, yes, but a lie nonetheless.
Wow.
When a developer takes your design and actually turns it into HTML, CSS, and JavaScript, they are creating the first true implementation of the product.
Not the final implementation.
Right. The text argues that the designer's involvement in QA isn't about checking if the developer knows how to code. It's about testing that first implementation against real-world physics.
Oh, that's an interesting way to phrase it. Real-world physics.
Yeah. Because when you load that coded screen onto an actual physical smartphone, you might realize that the touch target you designed, which looked huge on your 27-inch 4K monitor.
Yeah, my massive retina display.
Exactly. You realize it's physically impossible to tap accurately with a human thumb while you're, like, walking down the street.
Okay, I've actually seen that exact scenario play out.
Right.
You design this custom drop-down menu that looks absolutely gorgeous on the canvas.
Super sleek.
Yeah. But then, when it's built and you test it on an actual mobile browser, you tap it, and the native operating system's keyboard pops up and completely covers the bottom half of your custom UI.
Oh, man. Yes.
And your prototype couldn't predict that native OS behavior.
That is the perfect example of why this is so critical. And that's exactly why the feedback loop is mandatory.
Right.
The designer evaluates the precision of the implementation, not just for visual fidelity, but for tactile feel.
The real-world friction.
Exactly. You give feedback based on that physical testing, and the developer produces the second implementation. It is a symbiotic calibration. It's not a one-way inspection where you're just grading their paper.
I like that, a symbiotic calibration. But to calibrate effectively, though, you have to actually understand the mechanics of the person you're calibrating with.
Oh, completely.
We throw the word developer around like it's a monolith, but the ecosystem is highly specialized.
Very much so.
So let's get past the basic definitions. We know front-end developers code the interface the user interacts with, and back-end developers code the servers, the databases, the underlying engine.
Right, and the source text actually identifies the front-end developer as the designer's best friend.
Best friends, huh?
Yeah, because you share the same immediate concern, the user interface.
But here is where the friction usually lies in my experience.
Okay, lay it on me.
Designers often assume that because the back-end developer is dealing with, databases and server architecture, their work has absolutely no bearing on the visual design.
That is a very common misconception.
Right. Like, if I'm just designing the buttons and the layout, why do I care how the database is structured?
Because ignoring the back-end architecture is exactly how you end up designing interfaces that look beautiful but function terribly.
Interesting.
The text highlights a brilliant insight here. Back-end developers actually hold the keys to system latency and data structure.
And those dictate the UI.
Completely. They entirely dictate UI behavior.
Let's ground that in a concrete scenario so it's easier to grasp.
Sure.
Suppose I'm designing a really data-dense financial dashboard.
Okay, classic complex UI.
Yeah. I want a massive live updating feed of global stock prices, user portfolio changes, and real-time news alerts. And I want all of it populating simultaneously the exact second the user logs in.
Ambitious.
Right. In my design tool, I just drag and drop all those components onto the artboard. It takes me like 5 seconds to make it look like they all load instantly.
And visually, it's a masterpiece.
Thank you.
Your front-end best friend can even style the HTML and CSS to match your design perfectly.
Awesome.
But the back-end developer is the one who has to actually fetch that data from the real world.
Right.
They are going to look at your design and realize that pulling the stock prices, the portfolio history, and the news feed requires making 3 separate massive calls to 3 different external APIs.
And if one of those APIs takes 4 seconds to respond...
Your entire beautiful dashboard just sits there looking broken.
No.
Or worse, it freezes the user's browser while it waits for that one slow API to catch up.
This is a terrible user experience.
Exactly. So the back-end developer's constraint forces a design change. Can't just have a static screen anymore.
I have to adapt to the latency.
Right. You suddenly have to design complex loading states.
Okay, like what?
Well, do you use skeleton screens? Do you use a localized spinner for just the newsfeed while the portfolio loads first?
Oh, I see.
Or do you implement an optimistic UI update, where the screen assumes a successful action before the server even confirms it?
That makes total sense. The latency of the database call literally dictates the visual states I have to design.
It's exactly.
If I don't talk to the back-end developer, I'm essentially designing a frictionless fantasy.
A fantasy that will break on day one. And this is why the text also brings up the full-stack developer.
Ah, the hybrid.
Right, the hybrid who handles both front and back end. They understand both the database latency and the CSS rendering.
So they see the whole picture.
Yes, but regardless of whether you are working with a highly siloed team with separate front and back end devs or just a full-stack generalist, The communication relies entirely on how you package your intent.
Which moves us out of the theoretical relationship stuff and into the practical deliverables.
Let's get into it.
We need to talk about the blueprint itself. The source makes a hard distinction between a massive enterprise-level design system and a foundational design library.
They're very different beasts.
Yeah.
A full design system is a colossal undertaking.
Huge.
It includes brand voice guidelines, strict accessibility rules, animation physics, and fully coded React or Vue components.
That takes a whole team to manage.
It does. But the text recommends that even if you don't have the resources for that massive system, you absolutely cannot skip creating a design library.
Because handing a developer a massive file with 100 unorganized screens is like handing them a completed puzzle and telling them to figure out how the individual pieces were made.
That's a great way to put it.
A library forces you to isolate the variables, right?
Exactly.
You pull out the buttons, the text inputs, the drop-downs, the product cards, and you define them in a vacuum.
You are establishing the visual vocabulary before you try to write the sentences.
Oh, I love that.
And the source points out an interesting debate regarding timing here.
When to build the library.
Yeah. Some designers build this library at the very beginning of a project,
Okay.
which forces incredibly strict consistency from day one.
Makes sense.
But others wait until the end, once the creative exploration is completely done and the components have naturally settled into their final forms.
I can see the merit in both approaches, honestly. But here's a specific practice from the text that I find highly controversial.
Oh.
It suggests adding CSS snippets right next to each object within your design file library.
Yeah, that's a big one.
For instance, next to my primary button, I literally paste the raw CSS code for its border radius, background color, and box shadow.
Right.
But why? If I'm working with a modern engineering team, they are likely using a utility-first framework like Tailwind CSS or maybe CSS in JS, like styled components.
Very true.
They are never going to copy and paste my raw CSS block. It's basically obsolete the moment I type it out.
You're focusing on the syntax rather than the semantics there.
What do you mean?
It's true. The developer will almost certainly discard your literal code string to fit their specific architecture.
Right.
But the text argues that providing those CSS properties is about setting a rigid baseline of intent.
Intent over execution.
Exactly. Think about how a web browser renders a drop shadow compared to how, say, Figma renders it.
They use different rendering engines, right?
They use entirely different underlying math. So if you just hand the developer a visual picture of a button with a shadow, the developer has to eyeball it.
Oh, I hate when they eyeball it.
Right. They have to guess. Is that a 12-pixel blur or a 14-pixel blur? Is the y-axis offset 4 pixels or 5?
And if they guess wrong, it throws off the entire spatial harmony of the page.
Exactly.
Right.
But if you provide the CSS snippet, even if they rewrite it into a Tailwind class like Shadowing D, you have explicitly defined the underlying math.
I see.
You have stated definitively box shadow, 0p by 4p by 12px RGBA 0000.1.
I'm giving them the exact recipe.
Yes. You are removing the cognitive load of guessing. You are speaking their language of properties and values.
It's almost like using Google Translate to send a message to a foreign colleague.
That's a good analogy.
The literal syntax might be slightly clunky or grammatically stiff, but the core data, the numbers, the directions, the raw variables, are transmitted perfectly without ambiguity.
And that data transmission is critical because human error is rampant in handoffs, which leads us directly into the tools we use to automate that translation layer.
Right, the software that acts as the courier between my brain and the developer's code
The
editor.
handoff tools.
The text lists the heavy hitters: SketchCloud, Figma, AvaCode, Zeppelin, InVision, and Spect.
These tools fundamentally changed our industry.
Ooh, for sure.
I mean, before them, designers used to literally draw red lines on their mockups,
The redlining days were dark times.
manually typing out pixel distances between elements. It was agonizing.
I don't miss it.
Now, the process is pure extraction. You just sync your design file, and the tool processes the data structure behind your visuals.
It extracts the precise measurements between elements, pulls out the CSS properties we just talked about, and pre-packages the image assets for download.
Right.
It takes the subjective visual and spits out objective data.
And that objectivity is a double-edged sword. The text issues a massive warning here about the hidden danger of these automated tools. They are ruthlessly exact.
I don't have eyes.
They do not possess human intuition at all.
I call them highly sensitive 3D printers. They don't know what a mistake is. They just print exactly what you feed them.
Consider the implications of a one-point grid misalignment.
Okay.
Let's say you are using a standard 8-point grid system, which is incredibly common in UI design.
Right, so my margins should be 16 pixels, 24 pixels, 32 pixels, and so on.
Exactly. But while you were dragging a text box on your canvas, your hand slipped.
Happens all the time.
And you accidentally placed it 23 pixels away from the edge instead of 24.
Visually, to the naked eye, on a massive zoomed-out artboard, I will never spot a 1-pixel difference.
You won't, but Zeppelin will. The automated tool will faithfully extract that exact measurement and tell the developer, hey, this text box requires a margin left of 23 pixels.
And the developer just copies it.
The developer, trusting the tool, codes a 23-pixel margin. Now, when that code renders in a browser, that odd number might cause anti-aliasing issues.
It gets blurry.
It can. It breaks the mathematical rhythm of the CSS layout, and it can even cause compounding fractional pixel errors on different screen sizes.
Because the developer assumes my 23 pixels was an intentional, calculated decision, not just a sloppy mouse slip.
Exactly. The machine provides a false sense of security. You assume the software is managing the handoff, so you don't need to be precise.
If you do.
The source text makes it extremely clear. The designer must rigorously audit their own files.
You have to clean your room before you invite people over.
You have to zoom in to 400% and manually snap those stray elements back to the grid before you ever upload to the handoff tool.
And it's fascinating that the text also acknowledges that these automated tools aren't a silver bullet anyway.
No, they aren't.
It mentions that sometimes you have to bypass the software entirely and build custom, dedicated manual style guides.
It happens more often than you'd think, especially on highly complex custom software builds, where standard CSS extraction just doesn't capture the nuanced logic of the interface.
Like weird state changes.
Yeah, sometimes a bespoke manual document detailing the exact state changes and conditional logic is vastly superior to an automated data dump.
But whether we use a highly advanced tool like Figma's dev mode or we write out a manual guide, the output is always framed in a specific syntax.
Always.
We are dealing in measurements, hexadecimal colors, Bezier curve coordinates.
It's all math.
Right. So if a designer wants true control over their work, they can't just be a tourist in that environment. They have to learn the local language.
Which brings us to arguably the most fiercely debated topic in our entire industry.
Oh boy. Should designers learn to code?
Specifically, bridging the gap by learning CSS.
The source takes a very measured approach to this, thankfully. It starts by offering a pretty comforting reality check.
What's that?
CSS is not a real programming language. It's not JavaScript or Python.
Right. CSS cascading style sheets is a declarative language, not a procedural one.
Explain the difference.
You aren't writing complex logic or loops or algorithms. You are simply stating rules. It's a collection of English language properties and values following a very strict syntax pattern.
Property, value.
Exactly.
So if I want a specific typeface, I just write font family, enter. If I want the text to be bold, it's font weight, 700.
It is incredibly literal.
And because it's literal, design software is essentially just a visual interface for writing CSS anyway. When I draw a rounded rectangle in my design tool and add a drop shadow, the software is instantly generating the equivalent CSS in the background.
The text actually drops a pretty common developer joke to illustrate how blunt CSS can be.
Oh, the display, none joke.
Yeah. When a front-end developer encounters a highly complex, buggy element on the screen that's breaking the whole layout, the running joke is that they fixed it by just applying the CSS rule display.
None. Which literally removes the element from the browser's rendering tree entirely.
It's gone.
It doesn't fix the bug, it just makes the problematic object cease to exist on the screen.
Out of sight, out of mind.
That's hilarious. But jokes aside, I'm gonna play devil's advocate here for a minute.
Okay, let's hear it.
I'm a designer. I learned color theory, spatial relationships, typography, and human-computer interaction.
Right.
I did not go to school for computer science. If I spend my time learning the CSS box model, Flexbox, and CSS grid, doesn't that inherently limit my creativity?
Why would it?
Because I'll start subconsciously designing only the things I already know how to code, rather than pushing the boundaries of what's actually possible.
It's a common fear, for sure. But the text argues the exact opposite.
Really?
Learning CSS isn't about becoming a production-level programmer. It's about understanding the physics of your medium.
But there's that word again, physics.
Imagine a sculptor who refuses to learn how clay dries. arguing that understanding moisture content limits their creativity.
Well, if they don't understand the moisture, the sculpture just explodes in the kiln.
Exactly. If you don't understand how the browser's rendering engine interprets a shadow, or how padding differs from margin, how can you design a layout that will actually survive being coded?
That's a fair point.
Understanding the box model, knowing that every single element on a web page is fundamentally a rectangle with padding inside, a border and margin outside, that completely changes how you group elements in your design file.
It bridges the communication gap.
Complete.
Instead of me telling the developer, can you make this card breathe a little more? It feels cramped, which is totally subjective.
You can say, let's increase the internal padding from 16 pixels to 24 pixels.
Then giving them actionable data.
You eliminate the friction of interpretation.
And the source is completely equitable about this, which I appreciate. It doesn't just put the burden entirely on the designer.
No, it demands that developers learn the basics of design too.
This is a crucial point. Developers often treat design as this elusive, subjective, dark art.
They think it's just making things pretty.
Yeah, they think it's a painting on a wall.
Right. But design is actually a rigorous, precisely planned set of mathematical rules.
It really is.
When a developer takes the time to learn about grid systems, typography scales, and baseline alignment, their entire approach changes.
So if a developer knows that the entire product is built on an 8-point spatial system,
Yes.
and they measure a margin in the design file that accidentally says 15 pixels,
They won't code 15 pixels.
because they know better.
Exactly. They will understand the underlying rule, realize it was just a designer's mistake,
Yeah.
and automatically correct it to 16 pixels in the code.
That's amazing.
The text explicitly states that when developers learn to view design as a system of rules rather than just random artistic choices, QA rounds drop significantly.
The back and forth just disappears.
The alignment issues vanish. The entire project becomes cheaper, faster, and far less stressful for everyone involved.
So we achieve this incredible mind meld. The designer thinks in flexbox and systems, and the developer respects the visual rules and the grid. But we hit a hard limitation when it comes to the actual literal pictures on the screen.
Ah, yes.
Because as powerful as CSS is, it cannot mathematically render a photograph of a person or a really complex organic illustration.
And that brings us to the physical deliverables, mastering assets.
The source makes a very clear distinction between what should be generated by code and what must be exported as an image asset.
Which has changed a lot over the years.
Historically, designers used to export everything as images. The buttons were images, the gradients were images.
Because older browsers couldn't render complex styles.
Right.
But today, modern CSS is incredibly powerful. Symbol shapes, complex gradients, double colorful drop shadows, custom strokes, all of these should be handled natively in code.
Why is that so important?
Because code is mathematically perfect, it scales infinitely, and most importantly, it requires almost zero bandwidth compared to loading an actual image file.
A few lines of text in a style sheet versus a 50 kilobyte image.
Wow.
The performance difference is massive.
Huge.
But then we have the non-standard items. Brand logos, custom iconography, background patterns, and photographs.
The heavy stuff.
These are the assets the designer must slice out of the file and provide to the developer.
And choosing the correct file format for these assets is not just a visual decision, it is a critical performance decision.
The text dives deep into the holy trinity of web formats, SVG, PNG, and JPG.
Let's break those down.
Let's unpack them, starting with SVG, because I feel like this is the one designers misuse the most. SVG stands for Scalable Vector Graphics.
The key word there is vector.
Right.
Unlike a digital photograph, which is a raster image made up of thousands of tiny fixed color squares called pixels.
An SVG is different.
Very. An SVG is essentially a text file containing mathematical equations. It plots points on a grid and uses math to draw lines and curves between them.
Which means an SVG doesn't actually have a fixed physical size.
Correct. You can scale an SVG icon down to the size of a smartwatch screen, or you can blow it up to the size of a stadium billboard, and the computer just recalculates the math.
It will never, ever get blurry or pixelated.
Never. The text strongly recommends SVG as the absolute best choice for flat shapes, custom icons, and vector illustrations.
And there's another benefit too, right?
Oh yeah. Because it's math-based, developers can actually manipulate an SVG with CSS.
Like changing the color.
Exactly. They can change the color of the icon on hover without needing to load a second image file.
That's incredibly powerful.
It is.
But vectors fail when you need to display something photorealistic or something with incredibly complex gradients and noise.
They just can't handle that level of pixel variation.
That's where we move to raster images, specifically the PNG.
PNG is the workhorse for complex images that require transparency.
Transparency is the key there.
Right. If you have an image of a product, say, a sneaker, and you want the website's background color to show perfectly around the edges of the shoe, you absolutely must use a PNG.
But the text introduces an absolute non-negotiable rule when dealing with raster images like PNG.
The @2x rule.
Yes, the @2x rule. We need to break down the mechanics of this because it confuses a lot of junior designers.
It really comes down to hardware evolution.
Okay, take me through it.
Years ago, screens had a 1-to-1 ratio between a software pixel and a physical hardware pixel.
1 dot of light for 1 pixel of data.
Exactly. But modern screens Retina displays on Macs, high-end smartphones, are high-density displays.
Right, they pack way more pixels in.
They pack twice or even 3 times as many physical hardware pixels into the exact same physical space. We call this the device pixel ratio.
So a 100 pixel by 100 pixel square on my screen is actually being rendered by a grid of 200 by 200 physical hardware light bulbs.
Exactly. So if you export a standard 1x resolution PNG and put it on a modern smartphone, the phone has a problem.
It doesn't have enough data.
Right. It has 4 times as many hardware pixels to fill, but only enough image data for 1.
So what does it do?
The phone's rendering engine has to guess what colors to use to fill in the gaps. It stretches the image, which causes anti-aliasing.
And the edges become blurry, soft, and terrible.
Just fuzzy and unprofessional.
To fix this, the designer must provide the developer with an asset that is exactly double the size.
Right.
So instead of 100 by 100, it's 200 by 200 pixels. And you explicitly label it with the @2x suffix.
The high-density screen reads that label, realizes it has all the dense data it needs, and compresses it down into the physical space.
Resulting in a razor-sharp image.
And in some cases, for the absolute highest-end flagship phones, you even need to provide at 3x assets.
Okay, so SVG for math and vectors, PNG for transparency. What about our oldest friend, the JPG?
JPGs are still the reigning champion for complex, full-color photographs.
Why is that?
The compression algorithm is specifically designed to handle the millions of subtle color variations in a photograph without resulting in massive file sizes.
It's just really efficient.
Very. However, the text adds a very nuanced tip here. If a photograph is relatively flat, meaning it has a very limited color palette, large blocks of identical color, and minimal noise, you should actually test exporting it as a PNG-8.
Really? To see if it results in a smaller file size than the JPG?
Exactly. Sometimes it beats the JPG.
I've always wondered about this whole format debate, and I want to push on this limitation.
Which way?
Internet speeds are absurdly fast now. We have 5G on our phones, gigabit fiber in our homes. Our screens are capable of displaying billions of colors.
True.
Why are we still obsessing over whether to use a JPG or a PNG to save a few kilobytes? Can't we just export everything in the absolute highest uncompressed quality possible and let the massive bandwidth handle it?
It's a compelling thought, but it completely ignores the reality of global infrastructure and device memory.
How so?
First, not everyone is on 5G.
Yeah.
If your app is used globally, you are dealing with massive variations in network stability.
Okay.
Second, and this is the big one, it's not just about download speed over the wire, it's about decode time on the device itself.
Decode time? What does that mean?
Yes. When a massive, uncompressed image arrives on a user's phone, the phone's CPU and GPU have to unpack that data and actually render it onto the screen.
Oh, I see.
If you send 20 massive uncompressed images, you will literally spike the phone's processor.
The phone has to work too hard.
Exactly. The screen will stutter while scrolling, the battery will drain faster, and the app will feel incredibly sluggish.
Ah, so sending heavy files is like forcing the user's phone to do heavy lifting just to look at a picture?
Performance is a design feature. Never forget that.
Absolutely. The compromise is always an active battle between maintaining visual fidelity and ruthlessly cutting the kilobyte footprint.
Which transitions us perfectly to the final, critical step of the asset pipeline.
The final polish. We know our formats, but how we actually execute the extraction makes or breaks the product.
Right.
The source discusses the efficiency of batch exporting first. Modern tools like Sketch and Figma have completely automated the slicing
It's
process.
so easy now.
You just select your layers, open the export panel, and with one click, you can generate the 1x SVG, the 2x PNG, and the 3x PNGs simultaneously.
The extraction is easy. The optimization is the hard part.
Right.
Optimization is the technical process of reducing the file's file size without perceptibly ruining the image quality.
And what are the actual mechanics of that? How do you make a file smaller without shrinking the physical dimensions of the picture?
There are a few different vectors for optimization. One is indexing colors.
Indexing colors, how does that work?
A standard PNG 24 can display roughly 16 million colors.
Wow.
But maybe your specific image only actually uses 40 distinct colors. An optimization tool will mathematically strip out the millions of unused color possibilities from the file's data table.
Oh, that's clever.
It drastically shrinks the file size, while the image looks exactly the same to the human eye.
That's brilliant.
Another massive, often overlooked step is stripping metadata, specifically eGET-IF data.
Okay, unpack eGET-IF data for me. Why is there invisible data hiding in my pictures?
When a digital camera, or even your smartphone, takes a photograph, it embeds a huge amount of hidden text data directly into the image file itself.
What kind of data?
It includes the exact GPS coordinates of where you were standing, the make and model of the camera, the shutter speed, the lens aperture, and the date.
But if I'm uploading a picture of a coffee cup to an e-commerce website, the user's web browser does not need to know the GPS coordinates of the photography studio.
Exactly. It is completely wasted bandwidth. Stripping that eGET-IF data out of the file reduces the kilobytes with zero impact on the visual pixels.
Now, here is where the text takes a very strong ideological stance that I find fascinating.
It's a hill they're willing to die on.
In modern development, there are automated tool scripts that run in the developer's build pipeline that can automatically compress and strip every image the moment the code is compiled.
Very common practice.
The developer doesn't even have to think about it. But the source argues vehemently that the designer must be the one to optimize the assets manually before handing them over. Why? Why not let the machine do grunt work?
Because the machine doesn't have eyes.
That's true.
Automated compression scripts apply a blanket mathematical formula to every single image. They don't understand the context of the visual.
Give me an example of how that goes wrong in practice.
Let's say you have a hero image with a very subtle, beautiful, dark gradient stretching across a night sky.
Okay, very moody.
An automated compression script looks at that and says, these dark blues are very similar. I'm going to average them out to save space.
And what happens?
That smooth gradient suddenly breaks into harsh, ugly, blocky bands of color. The visual integrity of the interface is completely destroyed.
The algorithm ruined the art to save a kilobyte.
Precisely. The text argues that the designer possessing the trained eye is the only person qualified to manage that compromise.
That makes a lot of sense.
The designer must manually adjust the compression sliders for each critical asset, finding the exact tipping point where the file is as small as possible before the human eye can detect the quality loss.
You maintain absolute control over the final visual fidelity.
Yes.
And for those listening who want to take control of this process right now, the text explicitly lists several free industry standard tools to help you perform this manual optimization.
Write these down. They are indispensable.
Yep.
The source recommends TinyPNG, which is incredible for both PNGs and JPGs.
I use that one all the time.
It's great, as well as desktop tools like Compressor, ImageOptim, and ImageAlpha. Running your exported assets through these tools before handing them to the developer is the mark of a true professional.
We have covered massive ground today.
We really have.
We completely dismantled the myth of the static handoff and embraced the QA feedback loop.
We mapped out the friction points in the developer ecosystem.
We learned why back-end latency forces front-end design decisions. We built rigid baseline libraries, navigated the hidden dangers of automated handoff tools, demystified the language of CSS,
Unpacked the vector math and high-density realities of assets.
and finally took manual control of our optimization.
We've basically tracked the entire life cycle of an idea crossing the threshold into reality.
As we wrap up this deep dive, I want to leave our listeners with a broader conceptual anchor.
Yeah.
We've spent an hour deep in the technical weeds talking about compression algorithms, API calls, and pixel density. But what is the overarching philosophy a designer needs to take away from this specific chapter?
Consider this. In design education, we spend years obsessing over aesthetics.
We do.
We study the golden ratio, typographic hierarchy, and color psychology. And those are unequivocally vital.
Right.
But the provocative truth is this. The most beautiful, groundbreaking, psychologically perfect user interface in the world is completely, utterly useless if it cannot be translated into a functional code base.
Wow.
If it cannot survive the rendering engine, the network latency, and the physical constraints of the device, it remains nothing more than a static painting. The true mark of a senior product designer isn't just the ability to create a stunning visual. The true mark of seniority is mastering the empathy, the cross-disciplinary communication, and the technical translation required to hand that visual over to a developer completely intact so it can actually be brought to life for the user.
Empathy acting is a hard technical skill. I absolutely love that.
It's the secret weapon.
It brings us full circle. You can't just draw the blueprint for the skyscraper and walk away. You have to understand the concrete, the steel, and the builders.
Absolutely.
Thank you so much for exploring this highly technical landscape with me.
It was a pleasure.
And to you listening, a final reminder that absolutely everything we dissected today is pulled straight from Chapter 28. Developer handoff of the book Design User Interface.
It's an essential read.
If you want to stop guessing, master this handoff process, and stop seeing your meticulous designs break in production, you need this resource.
Great.
Go to the show notes right now and click the link, https://hyporacademy.gumroad.com/book.
Great.
Or, to make it completely frictionless, just pull out your phone and buy the book by scanning the QR code of the book link provided in the description below.
So easy.
And before you put your device away, please follow the show right now for more technical design breakdowns and career-building content. We've got so many more systems and structures to unpack together. See you on the next deep dive.